limit as x tends towards infinity of the function x upon x plus sine x is equal to L. So we have to find the limiting value L for this limit. So it's really a nice question. So let's see how we'll discuss it. But before that, please do like, share, subscribe, and please support this video. Now let's start. So clearly in such kind of questions, you think of applying L'Hopital rule, and when you apply over here, let's see what you get. So when you apply L'Hopital rule over here, because you can clearly see it is infinity by infinity case, so you can apply L'Hopital rule over here. You can think of applying it. So you will get 1 upon 1 plus cos x. Now notice one thing. Cos x, when x tends towards infinity, is not defined. So does it mean that the limit does not exist? Well, the question becomes ambiguous now. Why? Because when you apply L'Hopital rule over here, you get does not exist. And if you apply this method, limit as x tends towards infinity x upon x plus sine x, you will get limit as x tends towards infinity 1 upon 1 plus sine x by x, and clearly sine x is lying between -1 to 1 and x is approaching towards infinity, which means that this limit is tending towards 1. So which is correct? Does not exist or 1? So for that we have to go in bit of details. So let's see. So clearly the limiting value is actually 1. But why, when we were using L'Hopital rule, why we got the result as does not exist? Because L'Hopital rule is a very specific case. I mean, when you say fx, limit as x tends towards some constant c, f of x by g of x, and if it is of the form infinity by infinity, 0 by 0, and so on and so forth, then in that case what we do is that basically we apply it for these two cases only. Rest, if it's infinity minus 0 case, sorry, infinity minus infinity case, then also you can take that expression common and then you can apply L'Hopital rule again, but it is again of the form infinity by infinity case or 0 by infinity, so it doesn't matter. 0 by 0 case. Okay, so it is basically used for two cases. Okay, so it is basically equal to limit as x tends towards c, f dash of f dash at x divided by g dash at x, and so on and so forth. The limit as x tends towards c, f nth derivative divided by g nth derivative at x. Okay, so it is valid till the time you are getting infinity by infinity case. Okay, but for this to be existing, we must end up with some limiting value. If we don't end up with some limiting value, then in that case either the limit actually does not exist or there might be some other method which you have to apply, the way we evaluated this limit. So let's move to the proof of L'Hopital rule to understand this. So we'll apply Cauchy mean value theorem. Mean value theorem. It states limit, not limit, f x minus f at a by g of x minus f of minus g of a is f dash at some c divided by g dash at some c. Okay. So this is Cauchy mean value theorem, and of course where the function is continuous for a to x. For this it is continuous, and for x belonging to open a to x, the function is differentiable, right? Okay, so c is lying between a and x actually. Okay, so let's assume function at a is 0 is equal to g at a. Okay, Okay. Or maybe you can, yeah, that is it. Okay. So you can say f at x by g at x is this quantity. Let's move to the next part. So you had got f of x divided by g of x is equal to uh, f dash at c divided by g dash at c. Right? You had got this expression for f of a is equal to g of a is equal to 0. Okay? Right? So now if you have to make it of the form 0 by 0, then what you will do? You can assume limit as x tends towards a, f of x, g of x, right? Now notice one thing, we had assumed that the function was the input, or you can assume it as suppose y for the time being. So this is equal to limit as c tends to a. Why c tends to a? Because now the limit has compressed. It has just ended to a single point at a. Means the limiting value at a, right? So it is tending towards a. F dash of c divided by g dash of c. So now you can say limit as y tends to a, f of y, g of y is limit. You can replace c with y tends to a, f dash at c divided g dash at c, provided this gives a limiting value L. Okay. So it means that L'Hopital rule is valid for many cases, but when it says that the limit does not exist, it can sometimes mean that you have to apply another method, or the limit actually does not exist. So you have to prove that this limit actually diverges, or it is converging to some value. You have to disprove the L'Hopital rule claim, or you will claim that yeah, the limit does not exist actually. So that is the theory behind this, the reason. So that is why this limit is tending towards 1. And the second thing over here, you can apply another rule also. Sin x is between -1 to 1. So x minus 1 is lying between x plus sin x to 1 plus x, correct? You can now take the inverse both sides. So you will get 1 upon x minus 1 is this 1 plus sin x, 1 upon 1 plus x. Now you can just multiply both sides by x, and since x is a positive value, it is tending towards positive infinity, it is a very big value. So clearly x will be much greater than 1. Okay, so we don't need to worry about the negative sign or anything like that. Okay, so you can multiply by x both sides, so you will have x minus 1 is greater than this quantity, 1 x upon sin x plus x greater than x upon 1 plus x. Now just apply the limit as x tends towards infinity. You will notice that this limit is tending towards 1, and this is also tending towards 1. So this function, as x is tending towards infinity, is lying between 1 and 1. So if a function is lying between 1 and 1, what does it mean? It means that the function is 1 itself. So it means that this limit is again equal to 1, right? So it is like a sandwich theorem, which you must have studied, right? So basically it is sandwiched between these two functions, the limit values of these two functions. Okay, and that is the reason behind this. So for this you have to go to the proof of the L'Hopital rule. From there you will understand that we have to apply Cauchy-Minimal theorem, and from there we come to this result. And for the existence of that result, this limit itself should exist, and if it is not existing, then it means that either the function, the original limit, does not exist, or we have to apply some other method, right? So clearly from here we can say that the limit does not exist was coming from L'Hopital rule, but it does not necessarily mean that the limit will not exist. It is just the drawback of L'Hopital rule over here. Okay, so that is the answer. And I am saying once again, if you get does not exist from L'Hopital rule, it is 90% times correct, but sometimes it means that we have applied the wrong approach. Okay, so that is the basic concept. So just either you can check it using another method, or you can just stick to your original point of this. Okay, you can apply another rule over here also. What rule? Well, let's leave that for now. Okay, I've already told two methods. There can be many other methods also, using which you can prove that this limit is tending towards 1. Okay, so that is the whole theory behind this, and I hope you enjoyed this video. If you did, then please like, share, subscribe, and please support this video. Bye bye, take care, and please share this video as much as possible. Bye bye, take care.